Hi, this is Bill Punch. This video is one of a series of videos used to support Michigan State University's Introduction to Computer Science using Python CSE 231. This particular video will cover the topics of Booleans, relational, and logical operators in support of subsequent videos which will do things like selection and repetition. Let's get started. So we want to talk first about what the Boolean variable is. A Boolean is another type, like strings, like integers, like floating point operators. Booleans are a type, but they support a very particular set of values which are only true and false. And you'll notice that true and false are capitalized. And that's important for Python because Python pays attention to type. It's capital T true and capital F false. Like the other types, if we were to run a type on the value true or a type on the value false, we would see that we would get the result bool. And bool is the official name for the Python Boolean type. So int for integer, str for string, float for float, bool for bool. These two simple values, true and false, are a basis of a whole area of mathematics called Boolean expressions, and we use Booleans extensively in many different aspects of computer science. The first place where we would use them is so-called relational operators. You've seen relational operators before. They're pretty much the same as you've always worked with a couple of changes because of the keyboard set we're working with. So we have the less than operator, the greater than operator. It's less than or equal, so a less than sign followed by an equal sign. Let me scroll up here. And then greater than or equal, a greater than followed by the equal sign. And then two kind of odd ones. We need to measure a quality, and remember that the equal sign is assignment, so we can't do that. So Python has chosen the double equal sign to represent equality, and then to represent inequality, the exclamation point in front of an equal sign, sometimes it's called, which is a strange expression, bang equal, like bang, you're dead kind of thing. So if we were to run these things, here's a couple of simple examples. So an integer 1 and an integer 2 equals 10 or 20, and we're going to do the comparison runs, and we'll do this whole thing. So int 1 is less than int 2, that's true. Int 1 is greater than int 2, that's false. Is it equal? No, it's not. Is it not equal? Yes, it is. So just like you would always use them, we do the comparisons using less than, greater than, equal, not equal, whatever, and it returns one of the two values, true or false. It's particularly good that Python does the following. If you get confused, and it's easy to do, between double equal, which is equality, and single equal, which is assignment, and you do something like the below, Python will help and remind you that you got this wrong. So if I had accidentally typed int 1 equals int 2 and used the single assignment operator, I would get an error. It says, I don't know what you mean here. I don't know what value to print. So this is a good thing. It helps to remind us that we use the right operator. We can do chain comparisons, which is nice, and again, it's the same sort of thing that you would have done in a regular mathematics class. I can say, is my int greater than or equal to 0 and less than or equal to 5 all at the same time by just typing the expressions together? Is my int greater than 0 and less than 11? And that all works in Python just like you would expect. So my int, which has the value of 10, is greater than 0, greater than or equal to 0, and less than or equal to 5. That's not true. But my int is greater than 0 and less than 11. That is true. And again, just like we had for the other relational operators, we get a value of capital T true or capital F false back. I've said this before, but we have to be careful with floating point operations because floating point operations are approximate. It's really a bad idea to say exactly equal to when you want to do something like floating point operations. Look at this example. Is 2 divided by 2 to a very small number equal to 1? It shouldn't be. It should be close, but it shouldn't be exactly equal. Surprisingly, if you do that, it comes out exactly true because in the approximate operation, it equals exactly 1.0. A better way, a more useful way is to say, hey, is my result between two very small values so that I know that within some approximation it gives me the right result. That is a better way to do the measurement. So if we evaluate those, we'd say that weirdly, the result of this operation is exactly equal to 1.0. True, not expected. This is a better result. Is it between 0.99 and 1.01, that is within 0.02 one way or the other? The answer is true. That's a better way to do the measure.